It's June the 26th, 2010. We're planting soybeans in Bailey, North Carolina on Rhodes Road, just off of 581 between Bailey and Spring Hope. These soybeans we're planting today are being no-till behind wheat. We're planting a Group 7 soybeans. It's kind of late in the year. This is the last barn for this year. The equipment we're running here is a John Deere 7520 and a 1730 11 row on 15-inch spacing John Deere planter. Some of the new technology we're utilizing is GPS automated steering. That's what this display over here in the corner is. As you can see, it's showing me a reference line. I lined the tractor up on, get as close as I can to 040. I'll back up a little bit. I'll set the planter down, engage the auto steer, and off we go. But what I'm doing here is I'm skipping every other pass. As you can see by the map here, everything that we've planted is white, and everything that hasn't been planted is green. I planted all the way across this farm, skipping every other pass, just to make it easier on the turn. So I'm not having to turn around so sharp every time. This is a vacuum meter planter. What that means, it uses a air vacuum to meter out the seed on a seed plate, so the spacing's equal, and you put in the same amount of beans to every acre you plant. We're using a computer track 350 monitor, and what that tells me is everything the planter's doing. It's constantly scanning through the rows and telling the seed spacing, or how many seed per acre, or I can get an average of how many seed per acre we're putting on all the rows, or the spacing. What this is telling me is we're putting a seed every 2.2 inches. This is a real high residue no-till application. So we're planting today during the heat of the day. It's about 97 degrees outside. Now I'll go back to the virtual highway to turn around again. Shorter rows in this field than most. This automated steering is a relatively new technology in this area. It's been being used out west, where there's a lot broader acreage, for many years now, but it just has caught on around here, and there's a lot of benefits to it. Using this automated steering, every pass is accurate. There's no overlap and no gaps in the field. So we're saving fuel, and we're saving seed, and we're saving time. And another good thing about the auto steer is it phases out these right here. They're called road markers. Without the auto steer, they're hydraulically controlled. I'll set one down to show. They're hydraulically controlled, and this blade down here will take and cut into the ground and make a little furrow. And what I use that furrow for is when I come down the next row, I drive the hood on them and try to right down that furrow. And with auto steer, it's not necessary. And with road markers, you can't skip every other pass, and that really saves a lot of time with the turnaround. We are planting in 4-wheel drive, and in this high residue, it's kind of slick, and the tractor will do a lot of spinning without 4-wheel drive. Now this no-till works, you can see it. There's a culture, a flat display with wave notches in it on the front of every row, and that cuts the residue and makes a really narrow tilled streak for the planter opener to plant the seed into. And all this over here is already been planted. If you can see it over there, that's the tripod, the base station receiver. And what that does is gives the GPS signal a constant, a stationary receiver that makes the correction signal a little more accurate, since the satellites are in orbit all the time. And that really helps out with the accuracy. So a lot of these newer systems don't require the tripods anymore. And then up here on top of the tractor, that's the tractor's receiver. That's what collects the signal from the base station and from the satellites that are in orbit.